We've talked about measurements and how the precision of a measurement is limited by the size of the increment on the measuring tool. The size of the increment is its unit and is the third critical piece of information that must accompany a value for it to be scientifically meaningful. Saying that I weigh 81.5 plus or minus 0.5 without specifying the units doesn't actually tell anybody anything. Is that in atomic mass units, grams, pounds, stone, tons? The increment on the scale was in kilograms, so kilograms must be reported as the units in my final answer. Scientific fields use the International System of Units, or SI units. In this system, there are 7 base units, each governed by a defining constant. You'll notice, for example, there's no unit for energy among these 7, so we have to build one up through multiplication and division. We'll start with the unit for length. That's the meter. If we divide that by time, we have 1 meter per second, units for speed and velocity. The change in velocity over time, or 1 meter per second divided by 1 second, is 1 meter per second squared, a unit for acceleration. Newton tells us that force is equal to mass times acceleration, so the units of force must be 1 kilogram times meters divided by seconds squared, or 1 Newton. Finally, if we expend that force over 1 meter of distance, we're doing work, a kind of energy, and our units are now 1 kilogram meter squared divided by second squared, or 1 joule. Since we can multiply and divide units to build them up, we can use the same method to cancel them out. For example, if we divide 10 meters by 5 meters, the meters cancel and we are left with 2. Not 2 meters, just the pure number 2. If we want to know the force per unit area, we divide 1 kilogram meter per second squared by meter squared. The meters again cancel to get 1 kilogram per meter second squared, or 1 Pascal. Let's try a few short examples. Okay, so how many seconds are there in 2.0 years? So first let's just write 2.0 years. And then we want to change the units on that. So what do we want to change it into? We want to get rid of years. And maybe let's go with days. I don't know how many seconds are in a year completely, so let's just say how many days per year. There's 365 days, except for every 4 years we'll add another one, so let's say 365.25 days per year. Okay, so this is going to let us cancel out years, and then we'll have a value for days. Next, we can convert days into hours. So we know that there's 24 hours per day. And there are 60 minutes per hour and 60 seconds per minute. And we can just go through and cross all those out as well. So now we have days for days, hours, hours, minutes, minutes. And the only thing we're left with is seconds. And then it's just a matter of multiplying all of the values together. So when you do that, you're going to find you end up with a number very much like 6.3115 times 10 to the 7 seconds. And so you might be tempted to say that that's your final answer right there, but let's look at the significant figures. When we started with years, there were 1, 2 significant figures, so we can only have 1, 2 significant figures in the answer. So we'll round that down to just 6.3 times 10 to the 7 seconds. And that is our final answer. Okay, for example number 2, we have a convoy traveling at 45 kilometers per hour. So let's just rewrite that. 45.0, that's 3 significant figures, kilometers per hour. Has to make a trip of 100 kilometers. So how many minutes will the trip take? So we want to get it into time. That means that we have to get this hours or minutes on top. Huh? So instead of that, let's say 100.0 kilometers times, and we want to make sure that we have the kilometers on the bottom of this so that it divides out. So 1 over 45.0 hours per kilometer. And then, of course, we'll have it in hours. So we want to multiply it by 60 minutes per hour. And this will give us our answer in minutes. Okay, so we know that because we can cancel out. So kilometers divides out kilometers, hours to hours. All we're left with is minutes. And 100 divided by 45 is 2.22. And multiplied by 60 gives us 1.332 times 10 to the 2 minutes, or 133.2 minutes. So again, we'll check how many significant figures we have here. So this is 1, 2, 3, 4, and it's divided by 1, 2, 3. And according to our rules, it's the least number of significant figures dominates here. So the maximum that we can have are 3. So our final answer has to be 1.33 times 10 to the 2 minutes. And we'll throw a square around that. Okay, now let's try example number 3. You are the leader of a small rescue patrol that's being launched by rowboat from a ship 12 nautical miles from shore. It's 0300 and sunrise is at 700 hours. You must reach shore 1 hour before sunrise. So it gives us 3 hours. Might as well jot that down there. Based on the sea state, the patrol will average 4.0 miles per hour. Will your patrol make it? 1 nautical mile equals 1.151 miles. Okay, so first let's just check how far this distance really is in the units that's going to give us the time that we're actually looking for. So 12 nautical miles, and we want to go from nautical miles into miles, so we're going to make sure that we have miles per nautical mile. And this is 1 nautical mile is 1.151 miles. So this gives us 13.812 miles. Okay, so some people make the mistake of taking their significant figures too early. Already here we have just 2 for 12 nautical miles and 4 for the miles conversion factor, but we're not at the end of the problem yet. So if we round too early, it's going to change the final answer. So until we get to the final answer, let's just keep all of the digits that are available to us. Okay, so we know the distance in miles and the speed that we can travel in miles per hour. So again, we want to get the time and our final answer for the units, so we're going to make sure that that's on top. So let's say 13.812 miles times our conversion factor is now going to be hours per mile, and that is 1 over 4.0. Or if you like, 13.812 miles divided by 4 hours per mile. And that gives us an answer of 3.453, and that's in hours. And, well, hours. And it's more than 3 hours. So even without going to significant figures, we can say that It's greater than 3 hours. Therefore, no, we can't make it. More correct would be to give the proper answer. So let's look. We have to have a maximum. We got 12 nautical miles here, 4.0 miles there. So we have to have a maximum of two significant figures. That would be 3.4 if this number weren't 5. So because it's 5 or greater, we're going to round up. And our final answer is it will take 3.5 hours. No, we will not make it before dawn. Dawn. Okay. And ideally, of course, we're going to throw a box around our final answer. Okay, and that's that. A surprising amount of the work we do in introductory chemistry and other introductory science courses boils down to measurement and unit conversions. So if you watch your units, they can be a huge help in determining how to find your final answers.